Hi guys. Today we're going to just talk a little bit about Earth's shape. You watched a video last week about Eratosthenes, a Greek philosopher, librarian from Alexandria, Egypt, who discovered that the Earth had a circumference of around 40,000 kilometers. Um, I want to talk about how we have evidence of Earth's round shape, and so I'm just going to go through some evidence. When I'm done, I want you to watch another video that talks about the Flat Earth Society. And the Flat Earth Society is a really interesting group of individuals that have this argument that the Earth is flat. I want to show you the evidence behind why it's not. So I'm going to just go through a few things that we have for evidence and show you a few things along the way. And this will be a very short lesson. Okay, so number one, how do we know that the Earth is not flat? Well, there's this evidence we call the appearance of ships on a horizon. And this is kind of an interesting idea that's been around for a long time. If you watch a ship sailing out directly out into the distant horizon, it appears that the ship is sinking. Now, the best way to kind of describe this is just by sketching it out. So I have here my whiteboard, and imagine, okay, here's the horizon, and we have a ship that's on the horizon going and sailing out away from you. So there's my really lame looking ship. Okay. Now that's at time zero. So time equals zero. So let's say about an hour goes by. You're still watching that ship. The ship is slowly sailing away from you. And this is time equals 1 hour. What is that ship going to look like if it's sailing directly into the board or directly away from you? Well, it's going to look either a lot smaller or it's going to look different. And what we see is, well, now we only see the top of the ship, okay, and the sail right here, in the mast. Okay, so that's at 1 hour. Now, what about after a couple hours? So let's just scroll on down here. All right, so here we have the ship after 2 hours. Time equals 2 hours. And now all we're seeing is the sail. Okay, so what happened to the ship? Where did it go? Is it sinking into the water? Well, we know that the ship is going to come back eventually. And so we know that this is just the idea that the Earth is curved. Okay, so to just describe this in a different way, here's the Earth, okay, in a curved shape, and here's you on shore, standing there, obviously not to scale. Okay, and here's the boat in front of you at time equals zero. And you can see the whole entire thing, right? Your perspective, you see the whole boat. But after some time, let's say time equals 2 hours, the boat is now over here. Still the same boat, still the same size, still the same mast, but your perspective, you can't see it anymore. It's beyond your vision. Okay? So the idea is it's sailing over the curve of the Earth. So that's just one evidence of Earth's shape. Okay? So let's go back to what we were just talking about and take a look at evidence number two. This one's interesting. Observations of the moon. So if you observe the moon during what's called a lunar eclipse, the shadow of the Earth is cast onto the moon, and what we get is a blocked out moon. And sometimes we actually have some light that passes through our atmosphere and hits the moon and it turns red. We'll talk about that later in the year. But as you watch the shadow of the Earth being cast onto the moon, the shadow is always this nice curved shape, which you can kind of see here in the picture. That's the shadow of the Earth. So whatever the shape of the Earth is going to be the shadow on the moon. And you can see that nice curved shape. And every time, no matter what, that's always a nice round shadow. Okay, nice curved shadow. All right, evidence number three. People living in different parts of the world are experiencing different times of day. So, how in the world is it possible that here in New York State, we're experiencing the like sunrise, let's say, but in the other side of the globe, they're sleeping? Okay, so why in the world, how is that possible? Well, it's only possible if the Earth is round. Okay, and the Earth is obviously spinning and rotating every day, and therefore we have different times of day. Okay, and you could talk to different people across the globe and be talking to them at the same time that we're experiencing morning, they're experiencing nighttime. Okay, so just that's an evidence number three. There's an argument against every single one of these put out there by the Flat Earth Society, which you'll see in the video, but this is pretty interesting. Okay. Evidence number 4, observations of stars. This is something that we're going to be talking about a little bit later. Polaris, which is the pole star or the North Star, can only be seen in the northern hemisphere. It's only visible in the north, above the equator, north of the equator. Other stars can't be seen, and from our perspective here in the northern hemisphere, we can't see the Southern Cross. So how is that possible? Why can we see some stars but not other stars? Well, the answer to that question really is the fact that the Earth is round. So let's go back to our whiteboard and think about this idea from a whiteboard perspective. So here's the Earth, okay, and we're looking. Let's say we're at 43 degrees north here, and we're looking at the North Star. We can see it in the night sky away from us out here somewhere. Now, the North Star is directly above. I'm going to slide this way a little bit. The North Star is directly above the North Pole, which we're going to learn about later on. It's much farther away, obviously. This is not to scale. But it's directly above the North Pole. Here's the North Pole right here. We can see it from our perspective. It's right over there. Okay? But from our perspective, here's the equator. We can't see any stars that are down south of the equator, like stars that are down here, because the Earth is in the way. Okay? So that wouldn't be possible if the Earth was flat. We'd be able to see all the stars. Okay? So the fact that we can see some and not others is really good evidence of Earth's round shape. Also, as we'll learn later on, the height of Polaris above the ground actually varies based upon your latitude, which is also proof that the Earth is round. Okay, so let's go back to this again. Evidence number 5, I probably should have put this as number 1. Space travel, right? We've sent satellites, we've sent men and women up into outer space, and they've taken pictures of outer space. In fact, we could take a live stream of the International Space Station, which is orbiting around the Earth at a very, very high altitude, and it's getting a nice image of a nice round curved shape. We also have pictures from much farther away, like from the moon. We can see the whole entire planet, and it's, again, still round. Okay, so that's, I would say, probably number 1 evidence is that evidence. Obviously, that didn't exist many years ago, but within the last 50, 60, 70 years, we have pictures from outer space. Okay? Evidence number 6, this is just kind of an interesting biblical connection. There's a verse in Isaiah 40 that says that God sits enthroned above the circle of the earth. Kind of an interesting idea. The interpretation of what the word circle is kind of debatable, but I just thought I'd throw that one out there, that this has actually been known for much longer than the last few years. Okay? All right. Now, how round is Earth? Is it perfectly round? Is it a perfect sphere? Well, it's not. What it is considered to be is what we call an oblate spheroid. And that term oblate spheroid just means that it's not perfectly round. In fact, it's a little bit fatter around the middle, around the equator, than it is along the poles. So the equatorial radius from the center of this picture to the outside is a little bit more than the polar radius from the center of the Earth to the poles. Okay? So it's not very noticeable. I mean, look at this. This is not much of a difference there. 6,378 kilometers, 6,357 kilometers. There is very, very little difference. Now, is this noticeable from outer space? Is it noticeable from a distance? No. The Earth looks like a perfect sphere. Okay? But if we measure it, it is actually an oblate sphere. And note the difference between them, because they'll ask you questions like, what does Earth look like? Well, if you're asking that question, it looks like a perfect sphere. What is it actually measured to be? An oblate sphere. Now you might be saying, well, why is it slightly squished in the middle? And that's because the Earth is kind of squishy, technically. From a geologic perspective, it's a little bit squishy. It's got a liquid and slightly plastic interior, and therefore has the ability to squish a little bit. And the fact that it's rotating at a very high rate of speed allows that squish to kind of be centered towards the equator. It's kind of like when you hit a tennis ball with a lot of topspin, it tends to squish the ball, and it squishes along the axis of rotation. And so this happens with the Earth too, okay? Because it's spinning and because it's kind of squishy, it will actually squish along the equator. Okay. So that's kind of the evidence. What I'd like you to do is check out the National Geographic video that I'm going to put a link to in the agenda. It's about 10 minutes long, and it's a worthwhile watch. And tomorrow we'll talk more about this. Okay, that's it.